Hey all, welcome to Homeschool, and today we are with one of the most wanted chapter of class 10 science, that is electricity, right? See, don't know why many of the children feel difficult with electricity. The moment I say numericals of electricity or the various concepts, somewhere most of them lag the concept clarity. Maybe that is the reason you people feel numericals very difficult. But once you have 100% clarity on a concept, you should dig the concept and understand it, right? You should have that feel of understanding. You should have that feel of satisfaction in understanding the concepts. Only then you feel the concepts easier and you can able to solve the numericals very easily. So here I have come up with this particular chapter specially to make you understand the concepts in a detailed way, to bring the 100% clarity on each and every concept. Okay, and I am here to make you all experience the feel of understanding, the feel of depth that is there in a concept, right? So let us start with a chapter. Say electricity is not a new term for us, right? So electricity is a word, we use it in a day-to-day life in various situations. Actually, we are completely dependent on electricity. I can clearly say that we can't live even for a single hour without electricity, isn't it? Say our fans work on electricity, our lights work on electricity, each and every equipment in our house. You take it refrigerator, you take it mixer, grinder, TV, even the mobiles, the remotes, everything is on electricity. They will work only on electricity, right? So we are so much dependent on this electricity. You know what? Long back, the scientist called Edison, Thomas Alva Edison, we all know this. So he is the person discovered electric light bulb. Electric light bulb, isn't it? So who discovered? Edison. Edison discovered this. So with the invention of electric light bulb, various scientists have studied the concept of electricity, various things that come in electricity, and the people started applying them in a real life. So they started inventing new things. So like that, the field of electricity came into advancement, right? So today, each and every human being is completely dependent on electricity to each and every activity that he is doing, right? Fine. Say in the chapter, coming to the chapter, we are mainly studying about electric current. Okay, initially we are starting with electric current. That is the first concept of a chapter, right? So in this particular video, I am giving detailed explanation about electric current. Electric current, right? And later we will go for studying electric potential. Electric potential and also potential difference. So actually there is a slight difference between electric potential and potential difference. So both of them we will discuss in detail. So these are the two concepts I will cover in this video along with certain numericals that is there in your NCERT textbook, right? So no worries, keep calm, right? And try to understand and enjoy each and every concept that I tell you, right? Fine. So first and foremost, I will start with electric current. So I said electric current. So what do you mean by electric current? Okay, first and foremost, I will try to give the definition for electric current that is there in your textbook, that we will learn for our board examination, right? And later, let us try to study in deep about the definition. How did the definition come from? what exactly is the meaning of that definition. When you study that in depth, you will have that feel of learning in physics. That you will come to know the beauty of learning physics, right? So let me give you the definition of electric current first. The rate of flow of charges. So definition is very easy. The rate of flow of charges is called electric current. That's it, right? But what is the meaning of the word rate? What is the meaning of this particular word flow of charges? So what exactly is the charge? So what do you mean by a charge here? First we will learn what do you mean by charges. Later we will study what is the meaning of flow of charges. And finally we will come to the word called rate. Clear? So now the big question here is, what do you mean by charges? Right? Say, if you want to understand about the word charges, we should go back to structure of atom. So I am going to the concept of structure of atom. So do you remember about the structure of atom that you have studied in class 9 chemistry? Right? So what is this atom? I'm going to a very basic level just to make you feel that beauty on a concept, right? So atom is a smallest particle present in every matter. So matter is what? Each and every substance that we see around is a matter. Say pen is a matter, board is a matter, human being, say I myself is a matter, you are matter, right? So we all know what is a matter. So matter consists of so many atoms, millions of atoms. So atom is the smallest particle of matter, right? Atom is smallest particle of matter. And now, if I draw the structure of atom, say in everything atom is there. That means in every body, do we have charges? Yes, charges are actually present in atom. So where are the charges present? Charges are present in atom. Got to know? So everywhere atoms are there. In me atoms are there. In your body atoms are there. In pen atoms are there. You know, everywhere atoms are there. So where are the charges present? They are present inside the atom. That means each and every body has charges, definitely, right? So now let us see where are the charges present in the atom. So how do you draw the structure of atom? This is a nucleus, right? And what is there inside a nucleus? Protons are there and neutrons are there. And outside the nucleus there are so many shells. This is how we represent the atom, right? So what is there in the shells? Electrons would be there in the cells, right? So this is how I represent electrons. Okay, so these protons and electrons are actually called as charges. So what do you mean by charges? Protons and electrons that are present inside the atom are called charges. Here. Got to know? You know, protons have positive charge on them. Protons have positive charge and electrons have negative charge. Okay? Negative charge. So in general we say electrons are negative charges, protons are positive charges. So there are two types of charges, guys. What are they? Positive charges, which are nothing but our protons. Where are they? Inside the nucleus. And we have another type of charges, that is negative charges. Where are they? They are also present in the atom, but outside the nucleus, in the shells, they keep moving. Isn't it? So these are the two types of charges, protons, electrons. Clear? Fine. Say in any body, Say I will take initially with atom. If a particular atom has more number of electrons and less number of protons, then that body is said to be having negative charge, having negatively charged. Okay, say for example, usually in the atom, you should know number of protons is always equal to the number of electrons, guys. That is the reason atom is always neutral. Okay, so in our body, every cell is made up of atoms only. Inside the atoms, you have protons and electrons. Number of protons is always equal to the number of electrons. Okay, so atom is neutral. But in any case, if you have taken out some protons, okay, then you will have more number of electrons. Electrons are negatively charged, no? So the whole body acquires a negative charge. Okay, then when the body is acquiring a negative charge, that is responsible for producing electricity. Okay, so each and every body, whether it has a positive charge or negative charge, depends on how many number of protons and electrons are there in that body. If a body has more number of electrons compared to a proton by any chance, okay, if protons have gone outside, then the body will have more number of electrons, then it is said to be having a negative charge. The body is negatively charged, we say. Okay, if the opposite case happens, if a body has more number of protons, in case if electrons have gone out in some particular activity, right, then the body will have more positive charges. Then that point of time we will try to say that the body is positively charged. Okay, so this is how actually different substances acquire positive and negative charge. They can have positive charges if they have more number of protons. They can have negative charge if they have more number of electrons. Okay, so anyway, say you just have to remember charges are nothing but protons and electrons. Where are they present? Inside the atom. Okay, and here for our electricity, okay, so electrons are very important. The negatively charged guys are very important because electrons will flow. Okay, electrons will actually flow from one atom to another atom, right? This flow of electrons generates electricity. This flow of electrons generates electricity. Okay, so here for electricity, which charges we consider? We consider electrons. For electricity, charges means electrons. Charges means electrons. The negatively charged guys that are nothing but electrons are our charges for the chapter. Clear? So what happens? How do these electrons move? Definitely, we know a concept that electrons keep moving in this shell, right? I'm not talking about that movement. Actually, this electron can jump to one more atom. Okay, so this moment is what very much important to create electricity. Yeah, and now let us see how this electron jumps from one atom to another atom, and in which substances electrons can jump from one atom to another atom, right? That is very much important to understand. And before we go to that, let us discuss one more thing. We know positive charges, two positive charges when I bring close together, two negative charges when I bring close together, they always repel. Okay, and you will find attraction between positive charge and negative charge. Okay, whenever I bring one proton and one electron together, attraction is possible. Okay, attraction is possible. But whenever I bring two protons together, or whenever two electrons are near to each other, they always actually repel. Got to know? So there is a repulsion between two like charges, and there is an attraction between two unlike charges. Clear? So this is what the basic concept on charges. And now what I just now said, electricity is produced when these electrons, when these negatively charged guys move from one atom to another atom. Right? Now let us discuss that concept. See everyone, we all very well know that electricity is passed easily in case of metals, right? We call them as conductors. So what do you mean by conductors here? Conductors are the one which carry electric current or electricity. Okay, electric current from one region to another region. Yes or no? So such things are called conductors. So the best examples for conductors are metals. Yes or no? Metals like copper, silver, aluminium, iron. All these are conductors. See, I told you electric current is nothing but flow of electrons. Say electrons will move from one atom to another atom, I said, and that is how electricity is generated, and that is how electricity is moved, right? And this flow of electrons, this movement of electrons from one atom to another atom is observed only in the case of conductors or nothing but metals. Okay, in all the bodies you don't observe the movement of electrons from one atom to another atom. Okay, see for example in our body we have so many atoms, like we have electrons. See, that means can we able to produce electric current? Is there an electric current passing in this body? Or this is a pen, right? So this is a plastic one. It has so many atoms. It also has electrons. Say in this, is the electrons can easily go from one atom to another atom and produce electric current? No. Okay, there are certain substances in our nature. Only in them we will observe the flow of electrons. That is the movement of electrons from one atom to another atom. Right? And let us see how it is. Say for example, this is our copper wire. Okay, I'm taking a metal, copper wire. It will have so many atoms. Say I'll just draw bigger one, copper wire. Imagine it has so many atoms. In between nucleus is there, one shell is there. Copper will have so many shells, right? So nucleus has protons and here electrons would be there, and outermost shell also electrons are there, right? Outermost shell in the sense you have an idea, right? The last shell. All this we discussed in detail in case of chemistry. If you want, you can just go to the playlist of periodic table and watch the videos. You will come to know what do you mean by valence electron, valence shell, outermost shell and everything, right? Okay. Say this is another atom. I'll draw another atom. This is a proton of another atom. It also have so many shells, and these are inner electrons, and there is one electron outside. Okay, and now I will take one more atom. Say this is a proton, this is inner shells, and you have electrons. So many electrons would be there in inner shell. Outermost shell has only one electron. Yes or no? Say, do you remember copper's atomic number is 29, electronic configuration 2, 8, 18, 1. Okay, say the last shell has only one electron. I am concentrating the last shell because electrons present in the last shell, we call this electron as what, guys? Valence shell. Valence shell electrons or valence electron, isn't it? We call this electron as valence electron, right? So this is how so many atoms are arranged in a copper wire. Many crores and crores of atoms would be there, right? So what happens is, this particular last electron, what we called it as valence electron, it will try to move to another atom. This is what we call free electron. Okay, this electron will become free. Simply it will not become free. Simply, it will not come out of this shell. You know, when I apply some energy, okay, when I apply some energy, right, when I apply some force, this electron can come out easily. In metals, the last electron can come out easily, because you know there is lot of distance between this electron and this proton, guys, right? See, these electrons cannot come out easily because the electrons are very near to the protons. So positive charge and negative charge attract, no? I said positive charge, negative charge attract each other, right? So these electrons are very near to the proton, say attraction you will find, but the last electron present in the last shell is very far from a proton, so attraction is very little. So you can able to remove this electron very easily with little amount of energy, but energy definitely you have to supply to bring out this electron. Okay, now this electron has become free. Okay, so this electron can enter into the next atom. It can settle in the last shell of the next atom along with this electron. Okay, and here what happens? The repulsion occurs. See, this electron and this electron, repulsion. This is negative charge, this is negative charge. So what happens? Repulsion occurs. Repulsion also occurs, and here also again when you supply certain amount of energy, you know, one electron or both the electrons present in the last shell can jump to the next atom. Okay, this process continues. From this atom the electron jumps to the next atom, and from this the electron jumps to the next atom. That is how actually the outermost electron, which has become free when energy is supplied, because of this free electrons, you know, they jump from one atom to another, from one to another, and this is what we call it as flow of electrons. This is what the meaning of the flow of electrons. So what is electric current, guys? I told you, rate of flow of charges. So here charges are nothing but electrons. So this is how electrons flow from one atom to another. This is how electrons move forward when it is moving in a particular direction constantly. Okay, a force is created, you know, that force is what we call electricity. Clear? So what is the meaning of flow of electrons? This is what. Now you got to know that depth. Now you understood what do you mean by the word flow of electrons, right? So this flow of electrons is observed only in case of conductors, guys, not in all the substances, because metals and conductors have free electrons. So how do you get this free electrons? The valence electron, the last shell electrons come out easily. Simply it will not come out, guys, when you supply energy only. Okay, so we take the help of certain energy and we will try to force the electrons to jump from, to flow from, to move from one atom to another, another to another. And this flow of electrons, okay, is what we call electric current. Okay, so now you understood the meaning of the word flow of electrons. So what do you mean by this rate? Okay, so rate means anything divided by time. So here anything is what? Charges. Charges, when I divide by time is what we call it as rate. Okay, see, in deep, if I have to tell you how many charges, like how many number of electrons are nothing but charges here. So how many charges and how much amount of charge is actually moving in a unit time. Unit time in the sense unit second, 1 second, or in 1 minute, how many number of electrons or how many number of charges are moving. That is what we call electric current. Okay, so anything divided by time, anything that is moving in a particular amount of time is called rate. Clear? So what do you mean by electric current? let us try to write the formula now. Now you understood the definition, right? So rate of flow of charges is called electric current. Now we understood. So when the electrons flow in a particular speed, in a particular direction, those negative charges create a force, guys. That force is only electricity. I have repeated once again to have more clarity. Clear? Fine. So now let us check the formula for electric current. Electric current is denoted with the letter capital I. Okay. So now capital I, that is electric current, is equal to, what is the formula? Charge divided by time. Okay, rate in the sense what? Anything by time. What is anything here? Charges, flow of charges in a particular amount of time. This is what? Electric current. Fine. So the symbol for charge is Q, right? The symbol for time is T. So what is I? I is equal to Q divided by T is the formula for electric current. Remember the formula. This is very, very, very important. Okay. So now let us figure out the units of I. Okay. So what may be the units of I? See, what is the unit of charge? Remember, guys, Coulomb. Coulomb is unit of charge. Okay, Coulomb. Coulomb is denoted with capital C. Okay, and what is the unit for time? Second, right? Remember these two. Second is unit of time. So substitute here, unit of I is what? We know I is equal to Q by T, right? So I is equal to unit of Q, unit of charge is what? Coulomb. I'll write Coulomb. Coulomb, that is capital C, divided by time, that is second. So what is the SI unit? I'm writing SI unit of I is equal to Coulomb per second. Okay, so this is the SI unit of electric current, Coulomb per second. But here we have a great scientist called Andrew Ampere. And this person has made a lot of contribution regarding electric current. Okay, he has studied so many things, did so many experiments, and he has given a lot of things in the field of electricity. So that's the reason, just to give honor for this person, Coulomb per second is also called as ampere. Coulomb per second is equal to ampere. Okay, so we can write the unit of electric current as ampere, that is capital A. Okay, so what is ampere? Can you define 1 ampere? This is a very famous question for CBSE board examination. So if I ask you to define 1 ampere, how do you do? See, ampere is nothing but Coulomb, capital C, divided by second, Coulomb per second, right? So if I put 1 and 1 here, see, what is the sentence you will create out of this particular formula? I can say 1 ampere is equal to, when 1 coulomb of charge passed in 1 second is called 1 ampere. Okay, so how do you define? 1 coulomb of charge when flows in 1 second is called 1 ampere. Okay, very easy. If you can remember this, it's very easy. 1 ampere is what? Coulomb per second, right? Coulomb per second, the unit only, just to give honor for this person, coulomb per second is also called as ampere. So what is ampere? Coulomb per, coulomb divided by second. So 1 ampere means what? If this is 1, if this is 1, then you will have 1 ampere, right? So how do you define, how do you frame a sentence for this particular formula? 1 coulomb of charge when it is flowing in 1 second is what? 1 ampere. Okay, so this is about the formula. SI unit, remember SI unit is not ampere, SI unit is coulomb per second only. Okay, just to give honor for this person, we call coulomb per second as ampere, right? So usually the unit for current is used is ampere. In a day-to-day life, we measure electric current in amperes only. We give unit as ampere only. But SI unit is coulomb per second. Clear? And we considered the smaller current. We always consider smaller currents, smaller electric current. Like say for example, we measure current in milliamperes. So 1 milliampere is nothing but 10 to the power of minus 3 ampere. We also take the current, we measure electric current in 1 microampere. Okay, 1 microampere is 10 to the power of minus 6 ampere. We always measure current either in milliamperes or microamperes. So this conversion factors you have to remember, right? So this is all about electric current. Now we will see certain problems on this. Sit here, try to understand this particular problem. A current of 0.5 amperes, okay, is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through a circuit. Okay, see, first let us try to write what is given. Okay, let us try to write what is given, right? So what is given? A current of 0.5 amperes. Current is given, that is I is given, right? You see the unit, guys, amperes means I. This is a unit of I. I is given, current is given. How much? I is equal to 0.5 amperes. And later, what is given? Of an electric bulb for 10 minutes. That means time is given. T is given. How much? 10 minutes. So what are they asking you to calculate? Find the amount of electric charge. That is Q they are asking you to find out. So what is our main formula? What is our formula here? I is equal to Q divided by T. Electric current is equal to flow of charges in a unit time. Right? This is our formula. So what is given? I is given, T is given. You concentrate the units. See, time is given in minutes. But what is the SI unit of time? It is seconds, right? So definitely, if time is there in a minutes or hours, it should be converted to seconds. Observe. Okay, you have to be very careful with the units. Say, what is the unit? What do you mean by ampere? It is coulomb per second, no? What is the SI unit we considered for time? Seconds. So here in the information, it has to be in a seconds. If it is not there in a seconds, you should convert it to seconds. It is there in a minute, convert it to seconds. So it should be converted to seconds. This is where lot of the people make mistake. Okay. So 10 minutes, we all know 1 minute is equal to 60 seconds. Right? So 10 minutes is equal to how much? So cross multiply 10 into 60, that is 600 seconds. Right? So now you put it in a formula. I is given. What is I? 0.5 amperes is equal to charge. We don't know. Charge is what? We have to calculate. This is question mark. Divided by time is how much? Time is how much? 600 seconds. Okay. So now cross multiply. Cross multiply 0.5 into 600 will give you Q, right? So what is your answer? 300. Q is equal to how much? Q is equal to 300. What is the unit of charge? It is coulombs. Coulombs is represented with capital C. If you don't mention the units, marks will get cut. Okay, so what is important here is write what is given. Next, writing a formula. Look at the units carefully. If time is given in minutes or hours, you should definitely convert it in seconds. So convert that, then you substitute in a formula, calculate whatever you want. And in the answer, you should mention the unit. You calculated the charge, and for a charge, the unit is coulomb. Coulomb can be represented with capital C, so you're putting C here. Right? Fine. Okay, so now you have a word here called circuit. See, you will see this flow of electrons only when the path is closed. This is what we call circuit, isn't it? See, we studied in our lower classes also about the circuit, right? Say, I told you, okay, this is a copper wire. See, we have a copper wire. Say, in a copper wire, if I have to observe the generation of electricity, how I can observe? Okay, say how electricity is produced, I told. You know, you have atoms in a copper wire. Electron will be flown from one atom to another, another to another, another to another, right? This flow of electrons create a force. That force only electricity, I told. Okay, but can you tell me, this electron simply will not come outside, I said. I told you, you have to apply some force or energy, right? So you want the help of some energy, right? So what we will do, we will take a battery or a cell. This will give us energy. To a battery, you know, battery will have a negative terminal and it will have a positive terminal, right? So I will connect the battery with one wire, okay, and here I will have a switch. Okay, this is what switch, and to the switch, you know, the wire passes, and this is how I will connect. This is a copper wire. This is a copper wire. Okay, so this is what the simple circuit actually. So this battery is the source of energy, guys. So battery has two terminals, negative terminal, positive terminal. In the negative terminal, you will have more energy, more electrons. Electrons always pass. Electrons flow from negative terminal to positive terminal. Negative terminal to positive terminal always. Okay, so this is the source of energy. This is giving energy. Say in this wire, lots of copper atoms are there. Say this is giving energy. With the help of this energy only, electrons are actually, what is happening? It is flowing from one atom to another, one atom to another. And this flow, when it is seen in only one direction continuously, electric current is produced. Electric current is produced. Say somewhere here, if I keep a bulb, this is what the representation for bulb. Okay, and what is this? This is switch. This is switch. Okay, so battery, from a negative terminal, energy comes. So with that energy, what happens? Electrons will flow in a wire, right? Electrons are going from one point to another, one point to another. So when the electrons are flowing, what happens? When they flow, a force is created, I told. That is what electricity. So when that force enters into a bulb, the bulb glows, right? This is how the bulb glows. And observe one thing carefully. To pass the electrons, you know, the path should be closed. There should not be any disturbance. Say if I break here, you know, if I break here, will the flow of electrons can continue? No, right? So circuit have to be closed. So remember one thing here, switch, I'm talking about switch. Switch on, in the sense, switch on means what? Circuit circuit closed. Means you have given a closed path, you have given a continuous path for the flow of electrons. Okay, so closed circuit means what? Switch on, whenever you on the switch. Okay, so closed circuit is what? Switch you have to represent like this. Okay, so whenever the switch is off, switch is off in the sense you are breaking a circuit. Okay, you are breaking a connection here, there is no connection. That means these electrons will stop here, it will not flow again, it will not flow further, it will stop because you have broken the connection. Okay, so broken the connection means switch off. It will happen whenever you off the switch. Okay, switch off in the sense open circuit. So always electrons flow in closed circuit. Electrons flow always in a closed circuit. Circuit have to be closed. Closed switch is represented like this. Open switch is represented like this. Okay, got to know? So this is what we call circuit. So what is a circuit here? It is a closed path where electrons flow. Closed path where electrons flow is called electric circuit. So only in an electric circuit you can able to make electron continuously flow with the help of a battery. Okay, these electrons continuously flow in one direction. Only then electricity is produced and the bulb can glow. Got to know? Anywhere if you cut the connection, electrons cannot flow, electricity, cannot produce. It cannot be produced, right? So the circuit is compulsory to observe the flow of electrons, that continuous path, and all the electrons should go in only one direction. All the electrons should go in one direction. This is direction of electrons. Direction of electrons. It should go in one direction. Only then you observe the current and the bulb glows. Clear? So this is the things about electric circuit. So usually, how do we represent a battery? We don't write it as battery, right? So how do we represent a battery? Normally in a circuit, so we put two lines, one smaller line, one bigger line. Battery is what? This is actually cell. Negative terminal. Okay, let me put positive terminal, negative terminal. This bigger line means positive terminal, smaller line means negative terminal. Okay, so if I have one more cell, okay, this is one more cell. Collection of cells is called battery. Okay, so this is how we represent a battery. Battery. This smaller line means negative terminal. Always electrons flow from negative terminal to positive terminal. Okay, electrons attract positive terminal, right? So electrons direction is always from negative to positive. Battery is that energy. It's giving energy for the flow of electrons in this copper wire, in this closed circuit. Okay, fine. And actually speaking, what is the direction of current? Direction of current is nothing but the direction of electrons only, no? When negative charge is flowing with a very high speed in a particular direction, the force is created, that is what electricity. So what is the direction of current or electricity? It is the direction of electrons only, no doubt. But conventionally, in the older time, what had happened is, the scientist thought that electric current is produced when positive charges are flown, right? So if you think that positive charges flowing, then direction has to be this way, right? Direction, this is the direction of electrons, no doubt. Okay, but conventionally, older scientists thought that electric current is produced when positive charges flow, but that is wrong. Now we got to know it's because of electrons flow. Okay, but according to those scientists, since they thought that electric current is due to the flow of positive charges, so they kept the direction of current as this way, from positive to negative. Okay, even now we follow this convention only, right? So this is what? The direction of current. Okay, see, I'll write here direction of current. Remember this is very important. Direction of current is positive terminal to negative terminal. Positive terminal. But actually speaking, electrons flow in this direction, negative terminal to positive terminal. So the direction of current produced also this way only. This is real guys. But according to an older scientist, conventionally, they thought that positive charges flow creates electric current. No. So they have given direction of current as positive terminal to negative terminal, and that only we represent even today. That only we follow even today. Okay. So just try to remember, direction of current is opposite to the flow of electrons. If the electrons are flowing from negative terminal to positive terminal, the current generated will be from positive terminal. Electricity generated will be from positive terminal to negative terminal. Okay, this is conventional way. Conventionally we represent. But in reality we know, when electrons are flowing from here to here, electrons is the one charges, right? Charges when moving only, that force is created, that force only we are calling electricity. So we know the direction of electricity or direction of current is this way, because electrons are flowing from this way only. But just to give that honor for the older scientists, they did not change the direction of current even after discovering electrons are the reason for the producing electricity. Okay, so they just kept the direction like this only, positive to negative. They started representing direction like this only. So remember, direction of current is from positive terminal to negative terminal, but flow of electrons is from negative terminal to positive terminal in a electric circuit. So this is what a small simple electric circuit. Clear? Fine. Now, how will you measure the amount of current that is produced in a particular circuit? It is with the help of instrument called ammeter. So what is this? Ammeter. Okay. So ammeter is a device. I'll write here. If you cannot see there, I'll just write here ammeter. So ammeter is a device that is used to measure electric current. So in this particular circuit, with the help of this much battery, this much volts of battery, if you want to know how much electricity is produced in this circuit, then you can always measure with the help of the instrument. And this always should be connected in series. Okay, so remember the instrument name ammeter is used to measure electric current. Clear? So this is all about electric current. We will see one more problem, one more question, challenging question that is there in our NCERT textbook. Look at the question carefully. Calculate the number of electrons. Calculate the number of electrons constituting 1 coulomb of charge. So you have 1 coulomb of charge. Charge is nothing but a group of electrons moving, right? So how many electrons will make 1 coulomb of charge? That's what the question. See, for this question, many of the teachers would give the formula Q is equal to Ne. Okay, Q is nothing but, we know it is charge, and N is nothing but number of electrons, and E is nothing but charge of 1 electron. Charge of 1 electron. Okay, so charge of 1 electron is 1.6 into 10 to the power of minus 19 coulomb. Okay, remember this value, guys. Charge of 1 electron is 1.6 into 10 to the power of 19 coulomb. Okay, so this much coulomb of charge means 1 electron. So 1 coulomb of charge will have how many electrons? Okay, so for that normally we use this formula. Okay, but you no need to use this formula. Just by a simple way, we can just, with the help of a cross multiplication, we can finish off the problem. I'll show you how. See here, we know charge of 1 electron is equal to 1.6 into 10 to the power of minus 19 coulomb. Okay, so this much coulomb means 1 electron. This is the charge. This is the charge of 1 electron. Okay, this much coulomb means 1 electron. Fine. And now 1 coulomb means how many electrons? 1 electron means this much coulomb of charge. So 1 coulomb of charge means how many electrons? Cross multiply. How do you do? 1 electron, cross multiplication, 1 electron into 1 coulomb divided by 1.6 into 10 to the power of minus 19 coulomb. Right? Coulomb gets cancelled. So I am calculating number of electrons, right? Number of electrons. So 1 divided by 1.6 is how much? 0.625 into, if it goes to the numerator, 10 to the power of 19, right? And this decimal point I'll shift here. If I shift there, what do I write? 6.25 into 10 to the power of minus 1, I can write this one, I shifted into 10 to the power of 19. So this will be 6.25 into 10 to the power of 18 electrons. Okay, so remember guys, 1 coulomb of charge will contain 1 coulomb of charge means how many electrons? How many electrons? 6.25 into 10 to the power of 18 electrons. Clear? So this is all about electric current, its formula, units, electric circuit and everything. So now tell me, have you got that feel of understanding a concept? Once you have this feel of understanding, you will enjoy the concept. So always try to study the concept in a deeper way. Study it from a much basic things. Okay, then you will feel the beauty of a subject. Clear? So with this, I end my session. So in my next video, let me discuss about the electric potential and potential difference. Till then, keep revising a concept. If you have any questions or queries, you can post it in a comment box and we will try to answer it. Thank you.